Hi everyone, my name is Madhura Bhave and I work for Pivotal on the Spring Boot team. Thank you all for being here. I know it's right after lunch and it's a tough slot for attendees to not fall asleep. I'll try hard, but don't fall asleep. So today's talk is about how to get productive with Spring Boot. It's kind of a loaded term, productivity. And as a developer, there's many ways to get productive. But I want to cover, as part of this talk, some of the things that I think are useful features that Spring Boot provides for application developers to be able to write their applications in a more idiomatic way, debug applications both while they're developing the application and in production more easily. So before we get started, I just wanted to get a little bit of understanding about where you folks are in your application development journey. So how many of you use Spring Boot? Almost all of you. And how many are still on Spring Boot 1.5? A couple. So just a note here, Spring Boot 1.5 has reached end of life this August, so I would highly recommend upgrading to Spring Boot 2.1, and we will be releasing Spring Boot 2.2 soon after the conference, so you can also upgrade to Spring Boot 2.2 once that is out. The agenda for today is kind of divided into 3 sections. So the way I see it, an application life cycle, it consists of different events in the app's life cycle. And these 3, getting started, development time, and production, I see as some important events in the application's life cycle. And as application developers, we try to give you the best possible experience that you can get to help you through these phases of the application. So the getting started experience is about if you're developing a new application, basically writing it from scratch, what are some things you can do to avoid getting into complicated situations that will cause your app to become this complex thing that none of the new developers understand what you did a year ago, or even you don't understand what you did a year ago because you complicated it. The development time is once you have an application ready, you might even have an older application which someone else wrote, and you, as an application developer, you're maintaining it and growing the application. So development time features a smooth development experience is very important. So we'll cover some of that and what you can do while you're developing the application. And then obviously, nobody just develops apps that don't go to production, I hope. I guess some apps don't go to production, but that's not the idea. Most apps want to make it to production, so we'll see how you can debug your application when there are issues in production and things like that. I think when you use Spring Boot, since all of you use Spring Boot, you already know that Spring Boot gives you this fast getting started experience and a smooth developer experience, and it already takes you quite a long way in terms of developer productivity. But there are definitely some things that you can do as an application developer to make sure that that experience is better. And I've seen that there are a lot of ways in which people write Spring Boot applications. There is a certain way to do things, but I've seen people, once their app starts getting a bit more complicated and it starts getting bigger, people tend to add different kinds of configuration in different ways, and then you can end up in a situation where you can't easily debug things. So let's get started with the getting started. I'm going to be flipping between code and slides, so if I'm going too fast, let me know. So I basically have this application here, which is, I've already got the commits lined up. I'm not going to write the code right now. I already have the code. I'm just going to check out the code one by one. So we can go from a getting started experience to a development and app growing kind of experience to what you can do in production. Okay, so this initial commit here, I'm just going to look at this pom.xml, and if you are familiar with Spring Boot at all, you are going to be like, why does this pom look the way it does? Because typically you don't declare your dependencies this way. You don't have these version numbers declared on the dependencies and things like that. But I wanted to show you why it's important to do things the way you do them with Spring Boot, and what are some of the things you avoid by using things in the idiomatic sense. So which is why I'm starting from scratch with the way you're not supposed to do things, and then gradually building the application up to the way that's, I think, better. So this application, it's a release notes generator for GitHub projects. So think of it like if you work for a company that has an organization on GitHub, and you have multiple projects within that organization, and you want to generate like a consistent set of release notes for every GitHub project in your organization, that is what this application basically does. I mean, it doesn't do it yet, but we'll build it up. So as you can see, I've defined some properties here. I want my Maven compiler source and target versions to be 1.8. As you know, the default, the base version for Spring Boot 2 and above is 1.8. I have some Spring Boot dependencies here, but just the very core dependencies. So I have Spring Boot and have Spring Boot AutoConfigure. And I'm using this 2.2.0.rc1 version, which is the latest release candidate for the upcoming 2.2 release. So if I run the application, can everyone see the code okay behind? Okay, so I'm going to run the application. And it did something. It printed your familiar Spring Boot banner, and it started the application. But as you can see that it just exited with code 0. And that's because we don't have any web server dependencies in our application or any Spring Web dependencies in the application. So there's no web server for Spring Boot to start up. Typically, if you're writing a web application, you would use the web dependencies. So I'm going to go ahead and add those to our application. So this commit that I just checked out, you can see that other than these initial 2 dependencies that we added, I've added Spring Web MVC, and these are some other dependencies which you need to get your Spring Boot web application up and running. So let's go ahead and run that. Okay, so the application tried to start up, and it failed to start. Can anyone tell me why it failed to start? So it failed to start because we are using the wrong version of Spring Framework for the Web MVC and Spring Web. And this is the kind of situation that you can get into if you're managing the dependency versions yourself. It's very easy for you to get out of sync with certain dependencies. Dependencies are not compatible with, all versions of all dependencies are not compatible with each other. And because we're using Spring Boot 2.2.0.rc1, that is compatible with Spring Framework 5.2.0. So, and we're using 5.1.9. So this failure analyzer that you get out of the box with Spring Boot, it says that correct the class path of your application so that it contains a single compatible version. So we will go ahead and we'll fix that manually for now. But ideally, you don't want to be in the business of managing these different dependency versions. You want a consistent set of managed dependencies that you can just add when you specify the version of Spring Boot that you want to use. So I've changed it to 5.2.0.release. And if I run the application, you'll see that the app is up and running now. It also started Tomcat on port 8080. So you have this web application running. But this was not the ideal way to get up and running with a Spring Boot web application. So how do you avoid these manually specified dependency versions in your POM so that you don't end up in this situation? And for that, Spring Boot has something called the parent POM. The Spring Boot parent POM, you can use it in your project. That is, you can inherit your project from the parent POM. And in that case, you just specify the version of Spring Boot that you want to use, and that will automatically give you all the managed dependencies that work with that version of Spring Boot. Not only that, it gives you an additional set of defaults that make sense for Spring Boot applications. So highly recommend using the parent POM if you aren't using it. I know that there are some organizations that have their custom configuration, and your applications might be inheriting from those parent POMs, but we'll see how you can use dependency management even with a custom parent POM. So the Spring Boot startup parent, when you add that, you get dependency management like we saw. You also get a default compiler level of 1.8. So those Maven properties that we'd added over there in the properties section, you don't need to explicitly add those. If you want a different Java version, you can definitely specify that, but by default, you'll get 1.8. There's also sensible plugin configuration, so whatever plugins we think are useful in a Spring Boot application, we provide sensible configuration for those plugins with the parent POM. And there's also sensible resource filtering for files such as application.yaml, application.-dev, or if you use profiles, those kind of application files. So those are some of the things that you get with the parent POM. Now let's go ahead and make use of that parent POM in our application. So I've just gone ahead and added the parent, and the version I'm using is 2.2.rc1. As you can see, I haven't yet removed these explicit versions from my dependencies, but in the next commit, I can do that. So the parent POM lets you omit the version from your dependencies, which is, I think it's a really useful feature. And it gives you a consistent set of dependencies, which when you upgrade your version of Spring Boot, those dependencies automatically get upgraded for you. With the parent POM, I also mentioned before that you might have a custom parent POM, which means you might not be able to inherit from the Spring Boot's parent POM, but you still want this dependency management feature that I'm talking about, right? Because it seems like it's a pretty useful feature. So you can use your inherit from your custom parent POM and use the Spring Boot dependencies BOM in your dependency management section. So you get the dependency management that you get with the parent POM. So if you add this to your POM, you can still omit the version numbers from your pom.xml. Are there any Gradle users? A few, actually quite a bit. So even with Gradle, you can get Maven-like dependency management features by using Spring Boot's Gradle plugin in combination with the dependency management plugin. So you can specify the version of Spring Boot that you want to use with the Gradle plugin that Spring Boot has. And the Gradle plugin was sort of rewritten in 2.0. And the way it works now is if you have the Gradle plugin in your build.gradle, and you apply, and you also have the dependency management plugin, that will give you the Maven-like dependency management features in your Gradle project. Cool. So great. So we've omitted our manual versions from our POM so far, which is looking good. Now let's go ahead and see how we can get some of these dependencies to look a bit less cluttered, in the sense that writing a web application is a pretty typical use case, right? As an application developer, you don't want to have to copy paste all of these dependencies in every web application that you write, and then sometimes you don't know what a certain dependency is doing. It's just sitting there in the POM because someone put it there and everybody's too scared to remove it. So to avoid things like that, there are these things called starters. And as you can see, I was able to replace like 6 of those dependencies with this one starter dependency. It not only makes the POM more readable, it avoids this kind of copy-paste, which also avoids errors in the future, because copy-paste can lead to errors. So adding this Spring Boot starter web basically gave you that entire set of dependency descriptors that you had defined manually in the POM before. And just to make sure that our application still starts up on Tomcat, I'm going to run it. Cool. So the app is up and running on Tomcat. Our POM is looking pretty simple now. We don't have any of the complicated dependencies. You don't need to know about that. Just remember Spring Boot starter web. A nice trick to adding these starters is you can just do starter, if I can type, web, and then IntelliJ will auto-complete it for you. If you use IntelliJ, maybe Eclipse does it too. I'm not an Eclipse user. Right. So what are starters? Starters are basically a one-stop shop for a set of dependencies. We have a bunch of starters that you get out of the box with Spring Boot. So with Spring Boot itself, we have a bunch of managed starters. So even for the starter, you don't need to specify the version, because those are managed by Spring Boot. There's no copy-paste for common use cases. So let's say you wanted to add OAuth to your application using Spring Security. You can use the Spring Security OAuth 2. If it's a OAuth client application, you can use the OAuth 2 client starter. Or if it's a resource server application, you can use the OAuth 2 resource, Spring Boot OAuth 2 resource server starter. Like I said, starters are also managed dependencies. And there are actually a bunch of community starters out there for a lot of community projects that are being developed that have integration with Spring Boot. So it's not just that we on the Spring Boot team, we create starters. A lot of people from the community have been creating starters. And I think we also list them on our GitHub repo. So if you're ever looking for any integration with, oh, does this thing integrate with Spring Boot and do they have a starter? Maybe you'll find it on our GitHub page listed under the starters. And you're probably wondering, like, okay, that's cool. I don't want to write an application from scratch. I don't want to know what the parent POM looks like the syntax for the parent POM. I want the structure of a basic application generated for me. So as some people say, you can go to the second best place on the internet, I think. I think production is supposed to be the first, but so you can go to start.spring.io, which is basically this site that will bootstrap Spring Boot applications for you. And you can use Maven, you can select Maven or Gradle. This is the new UI, by the way. It's, we've been adding more and more updates to start.spring.io this year. So this is kind of the new UI. It also has a dark mode. So you can generate projects from here. You can select the version of Spring Boot that you want to use. And then this search over here will add the starters that I was talking about. So you can add the web starter right from here. You don't need to remember what the coordinates, the Maven coordinates of that web starter are. If you want to add those OAuth things that I talked about, you can go and add them from here. Start.spring.io has this new feature since like a couple of months ago. So if you just want to look at what the POM looks like when you add these dependencies, you don't need to generate a project and download the zip. You can click on this Explore option, and that will show you what the structure of the generated project looks like. So you'll be able to see like what does the POM look like, so your parent is here, the dependencies that we added are here, and then the source will contain like the structure for a basic Spring Boot application. So this explore feature I think is pretty useful because sometimes you just want to add a few dependencies to your existing application, so you don't need to generate an entire project for that. You can just add those dependencies here and explore the project and copy paste those dependencies. All right. So that was kind of about the getting started experience and how you can avoid getting into a complicated build file when writing Spring Boot applications. So let's move on to development time, because I think that's what, as developers, we spend most of our time on, writing the code for our applications. And now I'm going to give you a little bit of a walkthrough about what the application does so that it's kind of clear what it does. So we have this basic application class. I'm sure all of you are familiar with it. It has the @Spring Boot application annotation. There is one REST controller, which is called for generating the release notes for the project that you want to generate the release notes for. And the REST controller basically calls this release notes generator, which, sorry, I'm going to remove all my breakpoints. I guess I was debugging something. It calls this release notes generator, and the release notes generator talks to a GitHub service which can talk to GitHub and get all the issues that went into that release for that GitHub project and form this content. It's basically Markdown, which you can paste into your GitHub release, and it's available there. So the project is, I think it's quite simple. The GitHub service, I don't think we need to get into the details of what the GitHub service does. It's just a service that talks to the GitHub API. Okay, so let's look at the controller. The controller is interesting. It takes this milestone number. So on GitHub, if you're not familiar with how GitHub projects are structured, typically there are these things called milestones, and you put issues in this milestone bucket, and when you release that milestone, you can get all the closed issues in that milestone. So that's why I have this milestone as a request parameter, and I'm specifying the repository that I want to generate the release notes for, also as a request parameter. For now, I have hard-coded the GitHub organization for which I want to generate projects, but we'll see how we can get away from that. So if I restart this application with all these changes, I'm just going to I'm curling the generate endpoint with milestone 2.2.0 and repository Spring Boot. So it returned like this thing in Markdown, which I can copy, and then if I am releasing a new version of my project, I can paste it here, and I can preview it, and I see like, oh, what are the changes in this milestone or in this release. So that's cool. Our basic project is working, which means we can add more features to it. So as you can see, all these issues are right now, they're not very structured. They're just all listed in one single list, so it's not very easy to read. So let's go ahead and try to divide these issues into sections in our release notes. So for Spring Boot, we actually do use an automated release notes generator for Spring Boot release notes. And we structure them according to like new features, bug fixes, and what were some of the documentation changes that went in. So let's go ahead and do that in our sample. So this commit is going to, I don't know why it keeps jumping to this file. This commit, what it does, it adds support for sections. So in the generator, we've added this thing called release note sections, which you can configure and then structure your release notes based on those sections. So that's about all the change I've made. The release note sections, it just has some logic to get the section based on the label for that issue and then make those release notes. So the thing is, when I'm developing this application and when you are developing your application as an application developer, obviously there are certain things that you keep changing and keep adding as you keep developing your application. And when you do that, it's kind of painful if you have to manually restart your application for every single change. So with Spring Boot, you can add this thing called devtools. Maybe some of you are familiar with it. It's also available on start.spring.io, I believe. You can add devtools to get this kind of smooth development experience while you're writing your application. And devtools is, let's take a look at our POM. DevTools is this single dependency that you need to add to the application. And I've made it optional true. That's kind of like a best practice, so that when you make it optional true, it doesn't get accidentally included in your, let's say like there was something else depending on that Spring Boot project, it doesn't get accidentally included as a transitive dependency in that project. So if you do use DevTools, try to use the optional true flag on it. I'm just going to run the application once manually now that I've added DevTools. I hadn't built it before. And now when I start making more changes to my application, so let's say I add some default sections, right? So in sections, I've added some default sections here, which are like new features. And if the issue has a label called enhancement on GitHub, then it'll show up in the new features section. If it's a bug or a regression, it'll show up under the bug fixes section. So I made this change, and now I don't need to manually restart my application. DevTools basically monitors your class path. So whenever it sees that there's a change in your class path, it will automatically restart the application for you. And there's different ways in different IDEs to update the class path. In IntelliJ, one of the ways to do that is you can use this build. How many people use IntelliJ? Oh, wow, good. Not that I am judging or anything. I'm just saying good because this is relevant then. So when I built the application using this build project thing, it updated the class path, and as you can see, I didn't have to manually restart the application. DevTools automatically did the restart for me. And if I curl the endpoint that we were looking at before, let me clear this. If I curl that again, you'll see that I won't paste it into, actually let me paste it into GitHub because the emojis are cool. Right, so we get these two default sections that we added. So there's the new features and bug fixes. You might be wondering why there are only 2 issues in our 2.2.0 milestone right now, and that's because we just released RC1, so we're still working towards the next milestone. Right, so I didn't have to manually restart the application, and DevTools did it for me. An interesting thing to note over here is, if you can see this, there's something that's logged here which says condition evaluation unchanged. And that is something that we'll take a look at a little bit more in detail, because I think that's another interesting feature that you get with DevTools. It's not just automatic restarts. DevTools gives you some other things that make your development experience a bit smoother. Right, so we looked at automatic restarts with DevTools. The condition evaluation delta, we look at that when we go back to the demo. There's also sensible property defaults that you get with DevTools. When you're writing your applications during development time, there are certain things that you might want to happen when you're developing and not happen in prod. So things like, let's say you're using a templating engine, right, like TimeLeaf or FreeMarker. By default, these templating engines, they cache compiled templates for better performance. So in development time, you kind of don't want to cache them because you're developing them. You want to see the changes. So with DevTools, you'll have caching turned off for templating engines. And there's other properties that get turned on, such as debug logging for web requests. I think that's another property that gets turned on. Obviously, if you don't want the property defaults that come with DevTools, you can turn it off using a property. And for static resources, you don't need to trigger an entire restart of the application, which is why it does a live reload. So live reload is this specification of the client and the server. And Spring Boot implements a very basic live reload server. So whenever you update your static resources, and let's say you have the live reload client running in your browser will automatically get the latest changes. Right, so I want to show you the condition evaluation delta and what that means. So this commit over here, add handler interceptor, what that does is it adds a handler interceptor. So basically every request that you make to this application, it's going to be intercepted by this handler interceptor. And the way we've added it is by extending WebMVC configuration support. And now once we add this configuration to our application, and let's say I rebuild the application, rebuild the application, DevTools should kick in. And as you can see, DevTools has logged this condition evaluation delta, and it says that there was a negative match on the WebMVC auto-configuration. So what does that mean? If you're familiar with the way Spring Boot auto-configuration works, this actually means that because of something in the user configuration, this caused Spring Boot's auto-configuration, which is the WebMVC auto-configuration in this case, to back off. So now you don't get, this application will not get any of the things that WebMVC auto-configuration configures for you. And typically in a web application, unless you really know what you're doing and you really, really want to customize your application, and that's something that maybe WebMVC auto-configuration doesn't give that to you, that only then do you want the WebMVC auto-configuration to back off. This is not a typical scenario, and I've seen that a lot of developers end up in this situation because they don't realize that extending WebMVC configuration support has caused WebMVC auto-configuration to back off. They're like, oh, why doesn't this work, and why doesn't that work, which is totally fair. And with the condition evaluation delta, you can tell which configuration caused Spring Boot's auto-configuration to back off, and maybe there's a different way to do that instead of extending the WebMVC configuration support. If you know about the @enable WebMVC annotation, typically on a Spring Boot application, you don't have to add that. Spring Boot's auto-configuration will already add @enable WebMVC for you. But sometimes when things get put on Stack Overflow or people get some answers from Stack Overflow, you tend to paste these annotations without really knowing what each annotation is doing. And the @enable WebMVC will have the same effect that extending this did, which means it'll cause our auto-configuration to back off, and then all the stuff that we configure in this auto-configuration, you won't get that. So I would suggest being pretty careful when you add things like @enable WebMVC or any such thing that turns off Spring Boot's auto-configuration. just be careful and know that that's what you want. So in this case, I don't want the web MVC auto configuration to back off, which is why I am, instead of extending that web MVC configuration support, I'm going to implement this web MVC configurer, which is one of the ways you can customize things and add handler and interceptors and other things to your application. So now if I build it, it restarted again. It's given you a condition evaluation delta again. And this time your web MVC auto configuration is in the positive matches, which means that even though you've added this web MVC configurer for customizing your application, the auto configuration is still kicking in and doing its own thing. So it's actually not backing off in this case, which is what we want. Cool. All right, so the next section is about troubleshooting auto-configuration. And I guess if you know a little bit about Spring Boot auto-configuration, it's a pretty powerful feature, right? It's an opinionated view of what Spring Boot thinks should happen in an application when it sees certain things on your class paths, when it sees certain beans or certain properties. And it's the thing that gives you that getting started, up and running, already configured application that you get. But sometimes when you start adding things to your application, you add more beans and more configuration, things can fail. Things don't work as you want them to. There are times when, like we just saw with the web MVC configuration support, we were trying to just add a handler interceptor, but that was going to cause a whole bunch of other things that you want in a web application to stop working just because you added that handler interceptor. And then you end up with comments in your code because you don't know what is turning off what, which ideally you'd like to avoid such situations. So I think as powerful as it is, Spring Boot's auto configuration, it's important to kind of understand and see how it works and how adding certain things to the application can switch off some things with the auto configuration, which is how it's designed to work. So let's say you end up in a situation where you start adding beans to your application, you start configuring the application with more complex things, and you don't know what's going on, like something else stops working. You can get the condition evaluation report by turning debug logging on. So we saw there was a condition evaluation delta with devtools, but that was kind of like just what this current configuration turned off. The condition evaluation report is a much larger report for the entire auto configuration that you get with Spring Boot. So it will give you a report of all the configuration classes that matched or didn't match the conditional annotations and everything. What were the positive matches? What were the negative matches? And you can really see if you wanted to add the configuration that you just added to the application. If you use Spring Boot actuators, you can get that also with the conditions endpoint. So you can hit Spring Boot actuators conditions endpoint and see what conditions in the application matched and why did certain things make it and why certain things backed off. The last point, I think I find it pretty useful to look at the source of something when I don't understand what's going on. So as you know, Spring Boot is all open source. And if you think that there's something that's confusing, something that you don't understand with the auto configurations, you can always go to the source. So try to look for, let's say like you're developing the web application. So it's called web MVC auto configuration. The OAuth, if it's like an OAuth one, it would be called OAuth 2 resource server auto configuration. So all the auto configuration classes which configure stuff for you out of the box, they end with auto configuration. So try to look for those and see what are these classes conditional on. Like if I add this bean, will that cause this auto configuration to back off and things like that. So let's just take a quick look at what the auto configuration report looks like. So I can go to my run configuration and add, so IntelliJ has this checkbox for enable debug output. You can also do like a dash debug if you don't want to do that. And if I apply that and run the app, now I get a much larger report about what's going on in the application, not just the delta. So I'm not going to read everything, but if there's something that you see that, oh, this one matched this conditional on bean, and let's say that you had added a custom bean for that and you didn't want this one to match, you know that your bean is not kicking in because this auto configuration didn't back off. So there's something that's not right in that configuration. There's positive matches, and I think the negative matches are towards the end. And the source that I was talking about, you can look at, you can just go to WebMVC auto configuration, and you can look at the conditionals on this auto configuration. So you see that it's conditional on class servlet, so it's only going to kick in when it finds the servlet class and the dispatcher servlet class on your class path, which is why when we initially didn't have the web dependencies, nothing kicked in. And it's conditional on web application and conditional on missing bean. That's the one that caused our, when we added that configuration in our user code, that's what caused this one to back off, because this will only do it if it doesn't find a bean of type WebMVC configuration support in the user configuration. Cool. What's next? Okay, configuration properties. So I think if you've used Spring Boot, you're probably pretty familiar with configuration properties, but I'm going to quickly walk through configuration properties and why those can be beneficial and why they're easier to write and then read later if you're looking at someone else's code and things like that. So before configuration properties and before Spring Boot, the way you could externalize properties for your application was using this value annotation. I had to really look up how to use the value annotation because I've been using configuration properties for so long that I couldn't remember the syntax. But as you can tell, using the value annotation, it's pretty complicated in the sense that you have to specify the property that you want to externalize in this syntax with the dollar syntax, and then this is the default value for that property and things like that. So it's not a very easy to read syntax for externalizing your properties, especially if you have, let's say, more complex properties. So in here, in the generator, I believe. Oh. Sorry, I thought it was in, I think I rebased so that my commit disappeared. But the point was that value, the syntax is pretty complicated, and if you have hierarchical properties, so in the previous example, we were just specifying the organization name, but you have things like if you want to specify what a section looks like, so you have things like what's the title for that section, what is the emoji for that section, what are the labels for those sections. So it's kind of a hierarchical property structure. So in that case, the value annotation gets even more complicated, which means that you want to use something called configuration properties. And I don't know if this somehow messed up. Sorry, I think the rebase that I did just before the talk looks like it messed up my configuration properties. But I've added this configuration properties class in here, and instead of now using that value annotation syntax, I have this class which now it's basically a type-safe way of specifying properties that you want to externalize in your application. And you can specify a prefix over here. So there's release notes, and then you have nested properties under that. So I have some GitHub properties because if I want to connect to the GitHub API with a username and a password and the organization, I can do that here. The configuration properties classes are basically just created as beans in your application. So you can inject them in any other Spring component, just like it was any other bean that you'd created, and use those properties in those components. So in the generator, I've injected the release notes properties, configuration properties, and now I can just say properties.get/github.getOrganization. And the nice thing about configuration properties now with 2.2, if you remember in Spring Boot before 2.2, if you have a configuration properties class, you either have to annotate it with @component so that it gets created as a bean, or you had to go and add @enable configuration properties, release notes properties somewhere, so that Spring Boot knows that it needs to create a bean for these configuration properties. But the nice thing about Spring Boot 2.2, which is upcoming, is that you don't explicitly need to @enable configuration properties or add @component. We've added this thing called configuration properties scan. So Spring Boot will automatically scan for these classes annotated with @configuration properties and create those beans for you. So that's just one thing I wanted to mention as an upcoming 2.2 feature. Right, so just a recap of why you'd want to structure your code to use configuration properties. The value annotation is pretty tedious. With configuration properties, you can add stuff like JSR 303 validation. So if there's like a not blank or a not null property that you want to ensure, you can do that. You get auto-completion with configuration properties, and that can be done using this thing called the Spring Boot configuration processor. So when you add that dependency to Spring Boot and you have configuration properties classes, you can, in your application.properties files, you can get auto-completion for all the configuration properties that are available in your application. So you don't actually need to remember them, and it's pretty nice because then you just need to put in the values. And the last thing is with configuration properties, starting from 2.2 onwards, they are also immutable now. So the current configuration properties class that I've got here, it has a bunch of getters and setters for every field in that configuration properties class, and it can start to get a bit noisy. So with 2.2, there is support for constructor binding. So you can bind properties to the configuration properties class using constructor binding, and you don't need getters and setters. Well, you might need getters, but you don't need setters, and they're also, because of that, immutable. The star is for features that are new in 2.2. I know that's a bit subtle, but that was the point. The next thing is testing. I still have 20 minutes, right? Okay. So I want to talk about testing because as a developer, I think testing is really important. I think we can all agree on that writing tests for your application and not testing by just pushing your application to prod is probably a good thing. So we spend a lot of time as application developers writing tests, and it's not just about the experience of writing tests. Yes, we want things to be easy to test, and we want to do that, but the other thing about testing is you want your tests to give you fast feedback. So if you have tests that run on CI for hours, you probably end up ignoring some of them, or you probably end up being like, oh, okay, that failed, maybe it's okay. But if you have tests that give you fast feedback, I think you can write better tests in that case, and then the tests are then providing some value. So hopefully this commit isn't messed up, but let's see. In Spring Boot, I wanted to talk about this thing called slice tests. Have you heard, how many of you have heard of slice tests? 1, 2 people. Okay, so you know how we have we structure our tests, you have unit tests, you have integration tests, and then you also have this one layer, you can also have this one layer with your Spring applications, which is not necessarily a full integration test, but it's not even a complete unit test. So when I say unit tests, I mean tests that do not involve the Spring framework at all. You basically say new, so if I was unit testing this release notes controller, I would basically say in my test, I want a new release notes controller, and I'm calling generate directly and things like that. But in those cases, I'm not actually testing the annotations and the stuff that Spring Framework is giving me because it's a pure unit test. So I have these layers of tests in my application. Spring Boot test is an annotation that lets you write kind of the full integration tests for your application, where you can start up an actual web server, where you get all of the beans that you would get in an application that you were actually running. So here I've still written this mock bean for GitHub service. I don't want this test to talk to GitHub actually, so I've mocked it out. But it's still an integration. Test in the sense that it starts up the server. I can make a request to it using this thing called the test rest template. I'm hitting generate with a milestone and a repository. The only thing I've mocked out is the GitHub service in this case. So Spring Boot tests typically tend to be, I guess, the slowest. I guess if you have like smoke tests, which do a bunch of other things, those will probably be slower. But in this particular case, Spring Boot test will be slower because it will load up your entire application context. It will start up the web server and things like that. It is always good to have tests which have Spring Boot tests because you want to make sure that your entire application's context starts up and your beans aren't misconfigured and things like that. But for cases where you don't always need to start up the web server, let's say you're just trying to test this release notes controller, you don't need to have Spring Boot test give you the entire application context, because in this in the test for the release notes controller, you probably don't care about what the generator is doing or what the GitHub service is doing and things like that. So Spring Boot has this concept of slice tests, which basically what they do is they slice your application context depending on the beans that you need for that particular slice of the application. So now because I want to test the controller, I'm using this slice called the web MVC test, and that is going to give me an application, a much smaller application context than my actual application context, and I can use mock MVC to perform the request. So I'm still ensuring that all the annotations that the Spring annotations that are configured on my controller, they're all set up, but it's not starting up the web server. So it will be faster. And in this case, I want to test a failure, which I don't necessarily need to test it in Spring Boot test, right? Because this is something that is going to change in the controller. It's not going to affect the rest of my application. I need to make sure that when I hit this generate endpoint with an invalid repository, the controller says that it's a 400 bad request. And I can just make sure that that test passes by adding this exception handler in here. This exception in here, and then setting it with a response status of bad request. So just doing that will make that web MVC test pass. This is kind of an illustration of the slice test. So you have your application context with all your beans, and the beans are kind of layered in a sense, like there are some beans that you require for the web layer, there's some, like if you're using JPA, they're tied to your JPA layer and things like that. So when you have these different layers that you want to test, you don't necessarily need to load the entire application context for all those beans. So the slice tests give you a way to split that application context, which in turn makes the tests faster. There are a bunch of slices available with Spring Boot. These are still just a few of them. There are definitely more of them, but I haven't added them here. You can go to the docs and check them out. The other thing about testing is JUnit 5. I wanted to mention JUnit 5 because it is something that the Spring Boot starter test is going to give you by default. When you use Spring Boot starter test in Spring Boot 2.2, you will get JUnit 5 as the default. Let's say you're an application still on JUnit 4 that wants to migrate to JUnit 5. You can do that, and that is you can do that with the help of this vintage engine that helps you run JUnit 4 tests on top of the JUnit 5 test execution engine. With JUnit 5, you get a bunch of cool things like you can add the display name annotation, you can use nested tests and things like that. So it's definitely something I would recommend checking out. And the last thing in testing was test containers. If any of you heard of test containers? Okay, I'll cover it real quickly. So test containers is basically an open source project, and what it does is it lets you stand up a Docker container running like Redis, MongoDB, or anything basically that can run in a Docker container. Let's say your application needs to test against a Redis server and things like that. You don't need to worry about setting that up externally. You can use test containers. It has JUnit 5 support, and it basically starts up that Docker container if you have Docker running, and it gives you a way to get the host and the port on which that service is running in the container, and you can use those in your tests. Andy Wilkinson from the Spring Boot team is doing a much more in-depth talk about testing Spring Boot applications tomorrow, so I would highly recommend going to that talk. And the last bit is production. I will have to rush through these slides because I guess I have like 5 minutes. So production is important. And if you have apps running in production and you're on call, you probably get paged maybe in the middle of the night. And all you care about is, why is my app down? Why doesn't it work? It works locally, but it doesn't work on production. And let's say like what version of the application is running in production so that you can debug that version and things like that. So for this exact purpose, we have this thing called Spring Boot Actuator. It's a dependency that you can add to your Spring Boot application. It's basically another starter. So you can add Spring Boot Starter Actuator to your Spring Boot application. And that will give you a bunch of endpoints out of the box that let you debug some of those questions that were asked in the previous slide. So you can get things like application health, info. The info endpoint is going to give you stuff like the Git info. So if you add the Git plugin in your build file, you'll get all the Git info, such as what is the SHA of the commit that is currently running for this version. The environment endpoint gives you access to the Spring environment. So when you deploy your application, you have a bunch of things configuring that application with external properties, and you don't always know which value is getting set in your application because there are a bunch of property sources that kick in. So you can use the environment endpoint to look at what is being applied. Runtime configuration of loggers. I really like this one because it's one of the actuators which let you change the configuration of your application at runtime. So there is the loggers endpoint, and let's say like you're trying to debug why a certain component isn't behaving the way you think it is supposed to behave. You can change the logger level for that logger at runtime without having to restart the application using the loggers endpoint. And the JVM thread dump, I guess that's kind of a specific one, but I just wanted to mention it because it has some new features in Spring Boot 2.2, which I'll get to. So I'll just go a little bit into depth about some of these. There are more Actuator endpoints available. You can get a list of all the Actuator endpoints from the reference documentation. We have separate API, web API documentation for the Actuator endpoints. The health endpoint basically has these health indicators. So there's like a disk space health indicator. I think there's a Redis health indicator and things like that. And the endpoint will aggregate all the information from these health indicators and give you an overall view of your application's health. You can add custom health indicators depending on your use case. You can use the health endpoint in an authenticated and unauthenticated mode. I think this is important because when you have an app running in production, you have monitoring systems monitoring that app. So you can use the unauthenticated mode to keep hitting the application to make sure you're just getting a 200 OK response back from the app. And let's say you get like a 503 service unavailable. You can then log in as a user and get more details from the health endpoint. And health groups is something that has been added recently in 2.2. It lets you group certain health indicators depending on how you want to group them. The info endpoint, like I said, it can show you Git information, build information. So what's the artifact ID, the group ID, and the version of the application that you're running. And you can also add custom info contributors. The environment endpoint, I think apart from access to the Spring environment, it shows you which profiles are active. So depending on the active profiles, certain properties turn on and off. So you can see which profiles are currently activated. And you can also see the property sources in order of precedence. And if the same property is specified in multiple property sources, the one that has higher precedence, obviously that is kicking in. The loggers endpoint, I mentioned that. So it has a get, so you can see what the current configuration for all the loggers in your application is. And you can also update the logger configuration at runtime. And the thread dump one, so it basically provides a thread dump from the application's JVM. What's new in 2.2 is that it also accepts the text plain request. So you can set an accept header of text plain to the thread dump endpoint. And that'll give you a response that is compatible with these thread dump analyzers in case you happen to use those. And I just wanted to show you quickly how to add Actuator to your application. So it's, like I mentioned, it's just a starter. So you do Spring Boot starter Actuator to the application. The one thing I wanted to mention is that because the Actuator endpoints can contain sensitive information, so things like the Spring environment, or there can be other sensitive information which might be exposed by your actuators, they are disabled by default. So you need to expose them over the web explicitly. I would recommend doing this once you know that you've secured the Actuator endpoints with using Spring Security or something like that. But then you can turn them on, and then you get access to the Actuator endpoints. And that's all I had to share with you. Thank you.